page 4 of trig. This page is all about sine rule. So sine rule is used when you have non-right triangles instead of right triangles. So right triangles use SOHCAHTOA. Non-right triangles, you're going to use sine rule or cosine rule. We're only using sine rule today. The next video, when we learn cosine rule, then we'll talk about when you use sine rule, when you use cosine rule. But on this page, everything is sine rule. Okay. So what is sine rule? Sine rule is this rule right here. You don't have to use like 3 expressions equal to each other. You could just use 2. Okay. Usually you only use 2. But they just put 3 here because they're trying to show that, oh, actually, if you have a triangle, it has 3 sides, and you could have this equivalency for all side angle pairs. By the way, remember, if you have a triangle labeled capital A, capital B, capital C, capital A, capital B, capital C are the vertices or the corners of the triangle. Little a, little b, little c are the side lengths of the triangle, and actually the side lengths are always opposite. The capital A has the little a across from it, the capital C has the little c across from it, and the capital B has the little b across from it. So remember that that's like a math rule, okay? By the way, sine rule works like this. It also works inverted. So we could also have sine rule with all the capital letters on top. So we could rewrite sine rule like this. And sometimes this is useful, and we'll talk about that when we do the problems, okay? So the one written in the formula booklet is like this, but maybe what you could do when you're doing a trig problem is you could rewrite sine rule like this so that you have access to the inverted version also. Okay, so let's start with number 1. Find the unknown angle for each triangle ABC. So we have the first triangle ABC defined here. We can use the same picture for all of them. So for this first one, it says find angle A where side A is 12.5, side B is 15.4, and angle B is 68. So let's label each one of these things. So angle A, this is the angle that we want. We'll just mark it with a question mark. Side A is 12.5 long, so I'm going to label that 12.5. Side B is 15.4 long, so I'm going to label that 15.4. And angle B is 68 degrees, so I'll label that 68 degrees. Now what we're going to do is we're going to try to figure out angle A using sine rule. Okay, so remember, sine rule works like this. We want to find side angle pairs where we know both of the sides, know both of the partners, both the angle and the side, or we want to know one of the two. Okay, so like for example, 68 degrees and 15.4, we know both of the pair, so that's useful. 12.5 and question mark, we know one of the sides and we want to know the other side, so this is also useful. Okay, so these are the two side angle pairs that we're going to use. And what we're going to do is we're going to use part of sine rule. We're going to use the A pair because that's the pair, this pair here. And we're going to use the B pair because that's pair here. We're going to use these two, okay? So normally what we're going to do is we're going to immediately write down it just like in the formula booklet with the A and the B on top, the little a and the little b on top, and the and the big A and the big B on the bottom. But remember I said sometimes we might want to use this bottom one. When do we want to use the bottom one? Well, it depends what you want to know. Okay, and so in this case, the thing that we want to know is angle A, right? Angle A appears down here, right? We want to know this on the bottom. Remember, it's kind of a pain when you want to know, when you have an empty variable on the bottom and you want to find that, right? It's more work. So in this particular case, instead of using this one, I'm going to use this inverted version, okay, because then it's a little bit easier, okay? As we do these problems, it'll become obvious why this is easier, okay? So I'm going to copy down the other version, which has the sign on top and the sides on the bottom. Now I'm going to fill in some of the data here. So we know that small b is 15.4. We know that small a is 12.5. we know that angle A is what we want to know, and we know the angle B is 68 degrees. Okay, so now let's use the calculator to evaluate sine of 68 degrees so that we can fill that in and it won't look so intimidating. Remember, sine of 68 degrees, before we type this in, we're going to have to make sure that the mode is in degree mode. Good, it is. So mode degrees. And then we're going to do sine of 68 degrees by typing sine 68, enter. 0.927 is the answer, okay? So sine of 68 degrees, we can actually substitute in 0.927. All right, so now we have simplified. We have sine of angle A divided by 12.5 equals 0.927 divided by 15.4. Okay, now what we want to do is we want to isolate A. So in order to isolate A, first we're going to have to isolate sine A. So we're going to multiply both sides by 12.5. And if we multiply both sides by 12.5, then you see that the red 12.5 in the numerator and the blue 12.5 in the denominator cancel out. And then we are indeed left with just sine A on the left side. And then we have 0.927 times 12.5 divided by 15.4 on the right. Why don't we just multiply all that on the calculator? So we're going to have 0.927, which is this number that's already in the calculator. We'll just copy and paste it there. We'll multiply times 12.5. And then we'll divide by 15.4. And this will give us the sine of A. 0.72753. And last of all, we would like to isolate A. How do we isolate A? Well, we need to undo the sine function. Remember, the inverse of the sine function is called inverse sine. So we're going to inverse sine both sides. When we inverse sine both sides, inverse sine and sine cancel each other out. It's like matter and antimatter. It just blows up and leaves nothing. And then the right side is going to have an inverse sine there. So A is, I'm going to simplify it. A is equal to the inverse sine of 0.753. Which is equal to what? Let's see. Inverse sine, which we do by doing second sine. We just go up and copy this 0.753. And the answer is 48.8 degrees. So angle A is 48.8 degrees. And that is the answer to part A. Okay. Part B. Find angle B where, and then they give us the side length of B and C and angle C. We're going to draw a similar picture than they gave us. And this will be A, and this will be C, and this will be B, and this will be little b, and this will be little a and little c, always across from its big brother. Find angle B where little b is 42.8. So let's mark little b 42.8. Let's mark little c 30.6. Let's mark angle C 41 degrees. And we want to know angle B. So this is the one we want to know. So let's write our sine rule out. So this pair is important because we want to know one of the elements and we know the other element. We know 42.8. We want to know angle B, so that's an important pair. This is also an important pair because we know both. Okay, so we're going to use the B pair and we're going to use the C pair in this case. So I'm going to copy the B pair and the C pair, which would be these two. Okay, now do we want the little b and little c on top, or do we want the big B and the little big C on top? Do we want this one here, or do we want this one here? Let's look at what we want to know. We want to know capital B, so we want capital B on top. Okay, that makes it easier. So we'll put sine of capital B divided by little b equals the sine of big C divided by little c. And now we'll substitute everything in. Sine of big B, we can't simplify that because we don't know what B is yet. Sine of capital C, we can simplify that to sine of 41 degrees. Little b, we can substitute in 42.8. and little c, we can substitute in 30.6. Okay, so now let's simplify sine of 41 degrees. We can do that on the calculator. Sine of 41 is 0.656. And so now we would like to isolate capital B, but first we'll just need to isolate sine of capital B. So we're going to multiply both sides by 42.8. If we multiply both sides by 42.8, then we can cancel out the blue 42.8 on the bottom with the red 42.8 on top, and now sine B is almost all by itself. Sine capital B equals, and then on the right side we have 0.656 multiplied by 42.8 divided by 30.6. Let's simplify that with the calculator. 0.656. Oh, actually, we already have 0.656 right here, so we can just copy and paste it. And then I'm going to multiply that times 42.8. And then I'm going to divide that by 30.6. And that is 0.918. And now what I'd like to do is I would like to get rid of, or I'd like to isolate B, so I'm going to get rid of sine by operating on it inverse sine. Now I'm going to do inverse sine on both sides. Inverse sine and sine are like matter and antimatter. They blow each other up. I'm left with B equals inverse sine of 0.918. So what is the inverse sine of 0.918? Let's check it out on the calculator. Second sine is inverse sine. 0.918, that's the number that we have right here. 66.6 degrees. 66.6 degrees is the answer for part B. Okay? We just did that. Let's do the last one. Find angle C where A is 7.2, C is 5.1, and angle A is 70. So let's draw the picture first. Just draw the same triangle we have that they gave us. And so that'll be capital B, capital C, capital A. This will be little a, this will be little b, this will be little c. And little a is 7.2. Little c is 5.1. Big A is 70 degrees. And we want to know angle C. So we're going to have the A to A pair, and we're going to have the C to C pair. Okay, so we're going to have capital A or little a on top. Well, we want to know capital C, so we're going to put the capital letters on top. So we'll have sine big A over little a, and we'll have sine big C over little c. Okay? Let's substitute in some of our values here. So like, for example, capital A is 70 degrees, so this is sine of 70 degrees. Capital C, we don't know what it is yet. Little c is going to be 5.1, and little a is going to be 7.2. Let's do sine of 70 on the calculator to see what it is. Simplify it a little bit. So sine of 70 is 0.9396. The 6 rounds the 9 up, so it's 0.940. So now we'd like to isolate the big C, but first we're going to isolate just sine of C. So we need to multiply both sides by 5.1. If we multiply both sides by 5.1, then the 5.1s on the right side are going to cancel out, and we're left with just sine of C on top. And then the left side is going to have 5.1 times 0.940 divided by 7.2. So let's simplify that. The 0.940 is right here on the calculator, so I'm just going to put that there, and then I'm going to multiply by 5.1, and then I'm going to divide by 7.2. 0.666. And then I'm going to do the inverse sine in order to get rid of the sine C here. and they cancel each other out, right? And then I'm also going to do inverse sine on the right side. And so on the left side, I'm left with capital C. And the inverse sine of 0.66 is going to be second sine, copy that, enter. Answer is 41.7 degrees. Okay, so this is the answer to part C. Number 2, last problem. In triangle ABC, AC is 8, angle C is 101, angle B is 32. Find the lengths of AB and BC. When you have these brackets here, it just means the line segment. You might be familiar with the notation line segment AB, line segment BC, like that. Let's draw a picture. So we got A, B, C. AC is 8. Angle C is 101. Angle B is 32. And we're going to find the lengths AB. AB can also be called C because it's across from capital C. BC can also be called little a because it's across from angle A. So we're going to find A and C. Let's find first the one that's easier. The one that's easier to find is going to be this one. It's going to be the C's and the B's. Okay, why is that? Because we don't know angle A, and we don't know side A, so that side's a little bit more difficult. Now in this case, we're looking for side C, so we're going to do law of sines with the little c on top and the big C on the bottom. So we're doing C's and B's, right? So C's and B's. And then it's a little bit easier to do the algebra. So let's substitute in the values that we know. Capital C, for example, we know is 101 degrees. Capital B, for example, we know is 32 degrees. And small b, we know is, that's this, by the way, is 8. And small c, we don't know what it is yet, so we just leave it like that. Let's figure out what sine 101 and sine 32 are. Sine 101, enter. Sine 32, enter. And let's substitute those in. So 101, sine 101 is equal to 0.982. And sine 32 is equal to 0.530. Okay, so let's rewrite this. So I have little c. On the bottom, I have sine of c, which is also 0.982. I have 8 on top here. And then on the bottom, I have 0.530, which is sine of b, right? Now, if I want to isolate c, I need to multiply both sides by 0.982. And if I do that, then I end up with, these cancel out, so I end up with c equals 8 times 0.982 divided by 0.530. So let's do that. 8 times 0.982, which is right here in the calculator, divided by 0.530, which is right here in the calculator. And the answer is 14.8. So my length C is 14.8, and actually length C is the same thing as the distance AB, right? Length C is the same as AB. So length AB is 14.8. Now we want to know the length BC. The length BC is actually the A value. We can't find the A value unless we know the capital A value. And here's a little trick. If you know that 32 degrees and 101 degrees are the other two angles in the triangle, aren't all the angles supposed to add up to 180? Which means that angle A plus 101 plus 32 should be equal to 180 degrees. So actually angle A is equal to 180 minus 101 minus 32. So let's do that. 180 minus 101 minus 32. So the answer for capital A angle is 47 degrees. So since we know that angle A is 47 degrees, we can now do law of sines for small a. Since we want to know small a, remember, let's do small a on top and big A on the bottom. Do we want to use the B pair or the C pair? Well, it doesn't really matter, but the B pair here it's already fully developed, so why don't we write the B pair? So the B pair is actually, we can already go ahead and write that 8 is on top and 0.530 is on the bottom, because we already have it here, right? We have 8 on top and we have 0.530 on bottom. Let's go ahead and write it. It makes it easier. This is actually the B pair. We know that sine of capital A is 47 degrees, right? So this is sine of 47 degrees. So sine of 47 degrees, let's find out what it is on the calculator. It is 0.731. So this bottom part here is actually 0.731. Let's rewrite it now. We have little a divided by 0.731 is equal to 8 divided by 0.530. And now, if we want to isolate the a, we just multiply both sides by 0.731. And these two cancel each other out. And then I'm left with a equals, and I just have these three multiplied together or divided. So I have 8 times 0.731, which is right here. I just copy and paste it. It's always good to copy and paste it because then just round at the very end, right? And then divide by 0.530. 0.530 is right up here. Just copy and paste that. 11.04. If I round it to 3 sig figs, it would be 11.0. So the A distance is 11.0. A could also be written as distance BC, which is line segment BC's length. Okay? So that's it for this page.